take a look at our problem here. It's a related rates problem. All right, so we have a light pole, 20 feet high. And we have Chris, who's 5 feet tall, walking away from the pole. And we're given his speed, 3 feet per second. And the shadow that he makes is increasing as he walks further away from the pole. I want to draw a picture to describe the situation. And this is always an important thing to get a good handle on what's going on. It's good to see an illustration. And then we're going to calculate how fast the shadow is increasing when he's 25 feet away. All right. So let's see what it looks like here. There's our pole. It's 20 feet high. There's Chris. He's 5 feet tall. Here's the light from the top of the pole. Okay, and there's the shadow on the ground. All right, now let's see what happens as Chris moves away. First, let's label these. This is important to label our variables. So we have, I'm just going to call the distance that Chris is from the pole as x1, and the length of the shadow is x2. Okay, it's just good to have a name for these things. And as Chris moves away, his shadow lengthens. Okay, so that's what's happening here. Closer he is, the smaller the shadow. Further away, the bigger the shadow. Okay, that's pretty clear. So we have two triangles here. We have a large triangle, like that. And we have a small triangle here. So those triangles are similar. Okay, and we know the ratio of the sides because it's 20 to 5. Okay, so we're looking at this big triangle, small triangle, and we can set up a ratio here. Let's just pause it. Okay, so we have the base of the big triangle, x1 plus x2 here. And if I divide that by the base of the small triangle, it must be the same as the ratio of this side to this side. So it's equal to the ratio of 20 to 5. Okay, the ratio of the sides is going to be equal. So we can set that up, and we do some algebra here. 20 over 5 is 4. And we multiply by x2, so that's over on the right side from the denominator. Subtract x2 now, there's 3 left on the right side. And now we want to differentiate this. So we differentiate both sides with respect to time. And we're given dx1 dt. We're told that he walks at a speed of 3 feet per second. So we can plug that in there. And we have a 3 on each side, which we can divide by. And we're left with 1, which is the rate of change of the length of the shadow, dx2, that's the shadow, with respect to time. It's growing at a rate of 1 foot per second. Okay, so as he moves away 3 feet per second, the shadow grows at 1 foot per second. Okay, related rates. I hope that was helpful. And there you go. All right.